Hello friends. So in last lecture we discussed that the problem of a continuous subarray summing to a required sum, and we maintained two pointers f and b, and we solved that problem using our algorithm. Okay, we solved the problem, but why this algorithm works? Let us post-mortem the problem and the algorithm also, and look at how it is working and why it is working. The more important question, why? So this is our given array 1 4 23 25. This was our given array and we wanted a sum of 33. Starting from beginning, we reached to a subarray till element 10. So our f reached till here. We now start removing from back to get different subarray. But wait, so what we did is we reached till here and we started removing from this side. That is our f pointer, some call it back. So we start removing from this side. Okay, this side is clear, right? This side where our f pointer was there, to get various different subarrays. But wait, didn't we miss out subarrays like 423, 420, etc.? Yeah, these are actually missed out. Why? Because we have reached till 10 and we are not removing from this side anymore. We will be removing from this side only. And all the previous subarrays which we considered were starting from 1, because 1 had not been removed before. So now we have reached a point where our subarray contains elements till 10 and we start removing from this side. So we get 4 23 10, this subarray. Then we get 23 10, this subarray. If we remove one more, we get 3 10, this subarray. But wait, these kind of subarrays are left. We never considered them and will never be considering them in future. 423, 423, because 10 has already been added and it will not be removed before these are removed, 420 and 3. So 420 and 3 are left. So we are leaving some cases. We miss them out. So is it fine to miss them out? Let us see. We miss them out because we are not going to remove 10. It's on this side, B side. Okay, we remove from F side always. Yes, we missed them out, but it's perfectly fine to miss them out because 1 4 23, this sum was less than 33. Actually it was less than 33 because till then we have not started removing. We were just adding elements, so this sum was obviously less than 33. Hence none of its subarray can give a sum of 33. So 423 is indeed a subarray of this array, this one. So this itself is less than 33. So how can its subarray exceed or even be equal to 33? So none of its subarray is capable of giving me a sum of 33. So it's perfectly fine if we don't consider these subarrays. So considering those subarrays will be redundant effort anyways. So this was the point. Hope you understood this point. So next point, next minute point in the algorithm is, okay, so we reach this point 1 4 23 10 of f is here, b is here, cool. But why we remove from f side? That is, from this side we remove. We don't remove from this side and not from somewhere middle. Okay, we can choose from to remove from middle also. 20 we can remove. We can remove 10 also. But why we remove from this side only? Why we remove only 1? Okay, middle we can't remove because then the array no longer remains continuous. Okay, if we remove 20, then it will partition the array into 2. Subarray into 2. So 1 4 is one part and 3 10 is this part. But in the question it is given that the subarray should be continuous. So it violates that point. Okay, so no longer remains continuous. Removing from B sides, okay, takes us one step back. So let's say we remove one element from B side, we go one step back, so we reach 1 4 23. That is from where we started. We started from this point, we added 10 and just we are removing 10, so we are going one step back, so there is no point in doing that also. So there is only one option left. We try to remove from F side. And why we must remove? Because this sum is exceeding 33, so we must remove from somewhere to get it to 33. So we try, the only option left for us to remove is to remove from F side, so we remove from this side. So that's our only hope left, so that's why we do that. So I think you understand this minute point also and this minute point also. Let's try to understand the third and the final minute point also. Last important point, we remove elements from F side only till sum is greater than 33. As soon as sum becomes less than 33, we don't remove. So we remove this. So as soon as the sum becomes less than 33, we don't remove anymore. Okay, one more point is there. If it becomes equal to 33, as in our case, we removed one element, two element, and then the sum became equal to 33. So then we have got our answer. We just return from the function. We don't care anymore. We have got our answer. We leave. But if it becomes less than 33, we have to toil more. We have to put some more effort. So what we do is we stop removing, because if the sum has already become less than 33, if we remove more elements, then sum will decrease further. And the upcoming element might just be sufficient to make that less than 33. So our sum has already become 33 minus, let's say, delta, and the upcoming element is delta. So that upcoming element will make it 33, make the sum 33. So if we remove further without thinking about the future, so we are doing a bad thing. So we don't remove any further if once we reach less than 33, because the next element coming might just be sufficient to make it 33. So we continue adding more and more, and then we continue adding more and more elements. Again we follow the same steps. We add elements on this side till we get the sum greater than 33. If we get greater than 33, we start removing from back side. If we get equal to 33 at any point in the algorithm, we are done. We don't need to do anything else. But if it becomes greater than 33, start removing from this side. If it becomes less than 33 while removing, again add on this side. If it becomes greater than 33 while adding on this side, again remove from this side. And why we add on this side only and why we remove on this side only, that we have already told in the above 2 points. So I think all the 3 points are clear, and this successfully finishes our post-mortem. So one more point here. So while we read an algorithm, we should post-mortem like this. We should have a habit of post-mortem the algorithm like this, and understanding what all points are missing if we read that problem from the top. So we are just reading a problem and its solution, and we have just understood the solution. We can code it, but we should understand the minute points, because that is quite interesting and that is very important also. We can then, if we understand these minute points, then we will be able to design our own algorithms also. So this is quite important. Thank you, friends.